So next up, let's talk about the Avalonia architecture. By this, we are referring to specifically the rendering of Avalonia. The key to Avalonia is it's cross-platform everywhere. So when we're talking about the architecture, we mainly talk about how it draws controls on screen. That is one of the key things. So let's go over this article. This is to give you an idea, and you're not going to grasp this overnight and in one quick lesson, because this is obviously an advanced piece of software that's been written over years and perfected. But the idea is give you an idea of what goes on in the background. So the first thing is to understand the basic layering system of Avalonia. And you can see here we have a little grid, and it kind of goes from the bottom up in a sense. So the very bottom, it's got an underlying renderer, if you will, the thing that's going to render on the platform. You can see we have a Win32, Cocoa, X11, Wayland, Android, and browser WASM. So they're the things that we need to run on. They aren't the renderers, they are the engines that we need to effectively run on. This is the back-end platform system. And these are the things that then get abstracted out of there to be common. So we have the windowing systems, the inputs like keyboard and mouse, clipboards, dialogs, and GPU context. That's all we need to then make everything universal. Once you step up above that, the next layer is your basic composition. So Avalonia currently runs on Skia in the background as the universal graphics engine, if you will, that talks to the underlying hardware on each platform. And between the rendering and these layers is ultimately Skia sitting there to do the drawing. And then what we start with is drawing basic things like brushes, geometry, graphs, and general compositions. And then we can build that further up into visual trees, adding transformations, opacities, things like that. And then once you get to layout, you need to start doing a measure and invalidate kind of, measure and layout loop, if you will, which if you've ever been doing, say, DirectX back in the day, before we had any of these engines, you might be familiar with the closed loop of trying to draw any kind of graphics, which involved measuring your expected graphics and looping. And then on the top of that, you finally end up with all of your controls that can sit on top of all of this nice library that just works for us and we don't have to think about it. So it starts in the rendering pipeline, as we can see here. And we have a per frame rendering. So obviously every frame gets rendered to the screen. The start of this loop, so similar to a game engine, I guess, you process your inputs, you detect property changes, and then at this point you now do a layout pass. This is the kind of measure and arrange pass. So this is where all of your new calculated positions of elements that want to end up on screen are done. And we figure out the final positions of them. Then we do a render pass to actually draw to screen. And then the composition is the thing that finally sends that expected rendered visual, if you will, to the actual screen, and that's where it passes through Skia. And then if we want to go into more depth about each step, there's a nice handy little guide here that's very simplified in how it works, but ultimately still accurate. And you can see here is just an example of what happens during a measure override. It can go into, this will be similar for a panel or a grid or a stack panel. It's going to loop its children, it's going to ask its children to measure, and then it's going to return, obviously this is just a fake desired size, but you basically just loop over your child elements inside of the UI, measure them, and return ultimately the final size and position of the control that this is within. This happens for absolutely everything that has to be rendered on screen. It has to propose its size and position. And then what we end up with is called a scene graph. This is the expected position of everything on screen. It's not actually rendered to screen yet, that's the composition part. And you can see here it describes the scene graph as basically a lightweight tree of drawing instructions. So it's the graphing code of how we're going to draw this entire scene. There's obviously software rendering, so CPU side, and there's GPU rendering, which you always want GPU if you can help it. And then the problem with doing this, and the thing that Avalonia solved for the true cross-platform, is how do we go across Android, iOS, browsers, Windows, everything, and have this unified system where we can just generate UI that works everywhere? Well, that involves abstracting everything away from each platform. So this is what every single platform has to have in common. We need a render target, which is the place where we're going to actually draw graphics. So iOS, Android, Windows, they all have to report a render target, and the engine underneath handles drawing graphics directly to those underlying systems. You have other things, clipboards, top levels, windows. All of this then allows the platform to simply send the scene graph into the render target of each specific platform and doesn't need to know any more. And so long as those underlying render targets render the exact same graphics, then we have this unified UI that now works across all platforms. And then of course, now we've solved the rendering graphics to screen, these are the enhancements. So we have properties that we can tag into elements. For example, grid.row. I don't know whether we've actually done a grid in our UI, but if we were to do a grid and then inside of it we put a label, you can do what's called here an attached property. So now when we say grid.column, even though it's sitting on the label, it's telling this grid what column this element inside lives on. So this gets passed up to the grid ultimately, and the label doesn't care about it. Then we have the direct properties, which you've already seen. If we get rid of that, you can see these are direct properties, properties that simply live on the element and go back into the control itself. And then style properties. If we scroll down, you can see style properties can be applied in a style selector similar to CSS. So for example, if we wanted to style this calculate button, we could just go inside the button. So let's break this out now into an actual button. Styles can live in lots of places. We're going to nest it inside the button itself. And we're going to do that especially with button.styles. And that's going to now set the actual styles of just inside this button. And then as you can see here, we can do a style selector. So that would just be a style. We should be able to just do this special symbol, which selects the element that it's contained within inside of. So it should then be a button. We'll then do a setter, and let's just say set the background property. Okay, so it's not selected the right thing, so let's just do button in this case. Now we should have background, there we go, value red. And you can see there, we've now styled a button in red. So that's a simple style. We'll come to those in time. The visual and logic tree we've been over in the last video, so we won't touch on that. And one thing to bear in mind, just because in Avalonia you tend to use MVVM, so changing things like binding the title as we keep showing in here to greeting, and then we can change this greeting anywhere we like without worrying about threads because MVVM handles that for us. If we were going to do it manually, the UI is still single threaded. There's only one thread that is there to render to the screen as it should be. So if you are going to update anything manually, you still have to be aware of threads. If you do MVVM, this is of absolutely no concern.